So here in this chart represent our work. So our goal is to create a CI/CD pipeline which will automate all our development and deployment tasks. For example, here we can see that a developer will commit the code in the Git, for example, GitHub, and then when the developer commits, it will be triggered by the CI/CD server. The code will be pulled, and in this case mm, we are developing a Spring Boot application. So this, as it is Java code, we the Jenkins server will clone first and from the GitHub, and then it will package the Java file, all the Java files, and then it will build an image, Docker image, and then after building the Docker image, it will push to the Docker hub, and then as it's already ready to deploy, so we'll deploy our Java application to a Kubernetes cluster. So for this reason, we go to this side. For this reason, there are lots of ways to deploy a Kubernetes cluster. So we chose a k8s software for creating the Kubernetes cluster. So for this reason, we took an EC2 instance, and in that instance we installed k8s software, and we installed kubectl, AWS CLI, and from the k8s server we created a cluster, Kubernetes cluster. This is a cluster, and for our case we took two worker machine and one master machine. And then this is the Kubernetes cluster, and this is the load balancer for this worker machine. The end user, the user of the application, they will be able to talk with the application through via this load balancer. And we wrote from the CI/CD pipeline. uh, at the end, we communicate with this k8s server to deploy our application. We just apply the deployment YML file, which is located in the Git repository. In the deployment YML file, we mentioned to pull our already built Docker image from the Docker hub, and then it will be the application will be deployed to the Kubernetes cluster. At the end, we also apply logging system to our from our Kubernetes cluster. It will we for this reason we installed EFK, elasticsearch, kibana, and Filebeat. So Filebeat is will be installed in the Kubernetes cluster as a daemon set, because it will collect all the logs from each worker node. And we also install elasticsearch and kibana as a single node, single pod. And the Filebeat will send all the logs to elasticsearch, and elasticsearch all the logs can be accessed from outside using kibana dashboard. So developer can check the logs and can like check errors or any log system, any logs. So let's see this implementation in our how we installed, how we implemented this. So let's go to, so wait a moment. So this is our CI/CD server that we talked. This is the CI/CD Jenkins server, and this is the k8s server. And these are the Kubernetes cluster. One is one master node, two worker node. So here, this is the k8s server, this is the CI/CD server, and two worker node and one master node. So gradually we'll explain everything. And if we see the auto scaling group, which is responsible for creating our any worker node. So one two auto scaling group for worker node, one auto scaling group for master node. The responsibility of this AWS auto scaling group is that if any worker machine or any master or even the if master machine fails, then AWS auto scaling group automatically will create another master machine or another worker machine. So for example, if it goes down or if it is fails, then AWS auto scaling will create this another machine which will replace this, and all the states will be uh, resumed. All the data will be resumed on that new machine. So this is amazing, and it will be done with the COPS software. And this is the load balancer. It will be when we create the cluster, the load balancer is will be automatic load balancer, and auto scaling groups will be automatically created. This is the cluster load balancer. This is the API server for the Kubernetes cluster, and one load balancer is to access this application, and another load balancer is for accessing kibana from our side. So one load balancer for this, one load balancer for this, and one load balancer for Kubernetes cluster, Kubernetes API server. So these are the things, and this is our CI/CD server. We created a pipeline. We can see that this is for doc. First, let's go to the first. This is the git clone. This is the for Maven clean package. Building the Docker image and then pushing to the Docker hub, and then we just put another step to remove the Docker image because we don't need this in this CICD server, and then finally we deploy the Docker image to our Kubernetes cluster using this YML file. So we can in our Git repository we can see that there is a YML file here. So yeah, deployment file. Using this deployment YML file, we deploy this using kubectl apply to our COPS server. So this command will be run to our COPS server using SSH. Okay, and we can see these are very basic application. So this is an REST API. So we can just see that this is a test. It's very simple application. So and in the log we can visualize all the logs. So this is our package name from Java. This is the Java package name. We all can see all the logs of our Java application here. Here we um, prepare some logs for like test log. This is a log4j log visualization. For example, we can, if we see in the controller, if we see that test controller, so we put some logs here using our log4j library. So these these logs, so whenever any API calls, for example, it might be an information, it might be an error. So if any error happens in real application, so we can see the logs here. So if any logs happen, so we can easily check which API there occurs. So also we can see all the logs from the Kubernetes pods, Kubernetes clusters. All the logs we can see here. So if we go again to our diagram, so whenever this is our cluster and this is our COP server, even if we remove the COP server, our Kubernetes, once the Kubernetes cluster is deployed, it will not even if the COP server is deleted, so the Kubernetes cluster will be alive because of the autoscaling AWS autoscaling group. So we can recall all the steps again. So developer commits the code in the GitHub. Whenever GitHub has a new commit, the pipeline will trigger pipeline. So in the first step, it will clone, then package, and then it will build the image, and it will push the image to the Docker Hub, and then it will communicate to the COF server via SSH, and then from the GitHub, it will deploy the new image using kubectl apply to the cluster. So in the cluster, there are two workers node, and the application will be deployed in two workers node, and they have a load balancer. So it will be the user will access this newly applied application using the load balancer DNS server, and then at the end, developer can check any if any logs or any logs or any errors for the application, also the Kubernetes cluster, using the Kibana dashboard. So these are the final steps, or and for creating all these steps, we already wrote some tutorials. We'll here explain here, sorry, here we'll explain all the steps. We'll explain, we'll make a new separate tutorial for this, how to create all the cluster pipeline, everything. We'll create a separate video for that. Till then, goodbye.